right, folks, this is the last leg of our journey in Algebra 2, where we're going to finally finish up everything we need to learn about ellipses. And so our focus here today is going to be on this last target, where we're basically wanting to perform transformations on ellipses, slide them around, in other words, on the coordinate plane. So in this example that I want to do with you, it doesn't have you sliding yet. It's just revisiting the concepts we've learned about ellipses up to this point. What you'll notice is in this example, which I do know is in your notes, you're given the coordinates of both foci. And you'll also notice that these foci are sitting on the y-axis, 0, 10, and 0, negative 10. And we know that the foci always sit on the major axis, so this must be an example of an ellipse that is a tall ellipse. So we need to be referring to the part of our graphic organizer that is focused on tall ellipses. From the foci, we know we can always determine the value of c. So c must be 10. And remember, a, b, and c are always positive numbers. The focal constant is the length of the major axis. And if you look on your graphic organizer with a tall ellipse, we see that the length of the major axis will be 2b. So 2b must be equal to 38. Therefore, 1b is equal to 19. Now, to find the vertices, we see that the vertices are 0b and 0, negative b. So the vertices in this case will be at 0, 19 and at 0, negative 19. We already identified that the major axis is 2b, or 38. The minor axis, we remember when we look at our graphic organizer, is 2a. So we need to find a. Well, when we look, I think this red ink is hard to see, so I'm going to change colors. When we look at our graphic organizer, we see that there's a relationship between a, b, and c, and that is, with tall ellipses, c squared is equal to b squared minus a squared. So let's use that to find a. C is 10, so 10 squared is equal to b squared, which would be 19 squared, minus a squared. And we now want to solve this for a. So 100 is equal to 361 minus a squared. To solve for a, we'd need to subtract 361 from both sides. So we'd get negative 261 is equal to negative a squared. So finally, multiply both sides by negative 1, and you've got a squared is equal to 261. Of course, to determine the value of a and undo the squaring, you just need to square root, and that comes out to be about 16.2. So because our minor axis here is 2a, and a is equal to 16.2, then we know our minor axis length must be 2 times 16.2, which would be 32.4. Finally, the area of all ellipses, whether they're tall or wide, is always equal to pi a b. So we now know that a is equal to about 16.2 and b is equal to 19. So when we multiply 16.2 by 19, we get 307.8. So our area is about equal to 307.8 pi. Now here's an example of an ellipse equation that's not given in its typical form. It doesn't equal 1, it rather equals 24. Well, it's quite simple to get it equal to 1. We do that by merely dividing everything by 24. So we get this equation. Now, we want to reduce that equation, or reduce those fractions if possible. So if you just type 6 divided by 24 in your calculator, and then do your math frac key after hitting enter, you'll get 1/4. So this is 1x squared over 4. If you do the same thing with your y squared, take 4 divided by 24, enter, and do math frac, that's 1/6. So this is 1y squared over 6. And now it equals 1, so it's in a form we recognize. And then we can go about finding the vertices, the major axis, the minor axis, and so on, just like we did in the previous example. Notice here that b squared is bigger than a squared. That's what makes it a tall ellipse. So that's why we would refer to the tall part of our graphic organizer. So finally, we're going to want to be able to translate these translate these ellipses on the coordinate plane. And so the formatting didn't come out perfect here, but I have the equation x minus 2 quantity squared over 25 plus y plus 3 quantity squared over 4 is equal to 1. Well, I want you to notice that this looks similar to the equation for a circle, except that x squared and y squared are being divided by something, which is what makes it an ellipse. And we know that in a circle, h and k are the x and y coordinates of the center of that circle. The same will be true here with an ellipse. H, which in this case would be 2, and k, which in this case would be negative 3, remember it's just the opposite of what you see in the equation, will be the center of this ellipse. So I'm going to start by plotting the center point, 2, negative 3. So there's the center of my ellipse. Now I know that a squared is equal to 25, and therefore a must be 5. And I know that b squared is equal to 4, and therefore b must be the square root of that, or 2. So once you determine the center of your ellipse, all you have to do is go out right and left 5 places from that center, and up and down 2 places from that center. So I'll do that, and I'll do my best of graphing this here on my tablet, but I'm going to count out 1, 2, 3, 4, 5 places right of the center, right there, and 5 places left of the center would take me here. And then I'm going to go up 2 places because of the fact that b is 2 from the center, and down 2 places. And this is my ellipse. It's that simple. So it's like a circle, except that it's an ellipse. Now once you're looking at the graph of the ellipse, you can easily identify its domain by looking at how far left and right it goes. So the domain here would be everything from negative 3 to positive 7. So all x's greater than or equal to negative 3, but less than or equal to positive 7. The range is about how high and low it goes, and so we see it goes to as high as negative 1 and as low as negative 5. So our range would be all real numbers between negative 5 and negative 1. That's simple. So here we gave you an equation of a transformed ellipse, and we asked you to write its equation and find its domain and range. Well, one I'll give you the graph and ask you to write its equation. When given the graph, the first thing you've got to find are the coordinates of its center. The center point I see is 2 to the right of the origin and 1 down from the origin. So there's my h and my k. The second thing to determine is how far right and left we went to get to the edges of the ellipse. Well, from the center, it goes 1, 2, 3, 4 places. A must be 4. And from the center, it goes up 1, 2, 3 places. So the vertical movement is always about B. B must be 3. So now we just want to go to put this into the equation for our ellipse, which again looks much like that of a circle, x minus h quantity squared plus y minus k quantity squared is equal to 1, except that the x's are divided by a squared and the y's are divided by b squared. So h we've determined is 2. So we're going to get x minus that 2 quantity squared over a squared. Well, we've determined that a is 4, so a squared is 16. K, we know, is the y-coordinate of the vertex. And we can see the y-coordinate of the vertex is -1. So we're going to put a -1 in here for k, which makes this y plus 1 quantity squared over b squared. And we determined that b had a value equal to 3. So b squared must be 3 squared, which would be 9. And to finish our equation, they always equal 1. Fun stuff, eh? All right, so now once again we can determine the domain and range by just looking at how far left and right it goes and how far up and down the graph goes. So right and left is about domain. So I see it goes as far left as -2 to as far right as 6. So the domain would be all x's between -2 and 6. And we know that range is about how high and low it goes. So I see it goes as high as 2 and as low as -4. So the range would be all y's from -4 to +2. All right, guys, best of luck to you. If you have any questions, I will be here in the morning, and will also be available if you email me. So give it your best shot. This is the last new topic we need to learn. Woohoo!